All right, another way to write a function as a power series because as this form in this form. So one the problem say a r to the power n in this form. No, I think they say c x to the power n. So when it's in this form, we know the center is zero. So that is going to be Maclaurin. Okay, so when this is the power series that is Maclaurin series, we can also use the form of the Maclaurin series. We know that the function can be written at can be approximated using the Maclaurin polynomial, which is f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial, and then f triple prime of 0 over 3 factorial x cubed, and then f4 of 0 over 4 factorial x4, and so on. Okay, so this is the Maclaurin polynomial. Then in order to find the coefficient C0, C1, C2, so on, we can actually use up this hint. So we have, so in order to do this, we're going to have to take derivatives. So we have f of x is equal to 7 ln 6 minus x. So f of 0 will be 7 ln of 6. So that's going to be our C0. And then f prime of x gonna be derivative of ln u is u prime over u. So it's gonna be 7 times negative 1 over 6 minus x. So f prime of 0 will be negative 7 over 6. Okay, and then f double prime of 0 will be, so this is negative 7 over 6 minus x. If you want to find f double prime of that, we have negative 6 minus x to the power negative 1. So apply power rule and then chain rule, we will have positive 7, 6 minus x to the power negative 2, but of course times negative 1 because of the negative inside here. So we have negative 7 over 6 minus x to the power 2. And we know that since the function is rational function, the power in the denominator will be increased. So from 1 become 2, the next one will be 3, 4. So f triple prime of 0, we're going to have negative 7 times the negative 2, negative 7 times negative 2, and then the chain rule is negative 1. So we will have 6 minus x, negative 2. So f triple prime will be positive 14, 6 minus x to the power negative 3 times negative 1. So negative 14 over 6 minus x to the power 3. Okay, and then you can see the numerator is always the coefficient times the power, and the power increased by 1. So my f4 with the pattern that we have, oops, why do I write 0? So that should not be 0. That should be x. X, x, x. And then we're going to have negative 14 times 3. Negative 42 over 6 minus x to the power 4. If this is the fifth degree, then we're going to take negative 42 times 4 over 6 minus x to the power 5, okay? And then f double prime of 0 is negative 7 over 6 squared. F triple prime will be negative 14 over 6 to the power 3. And f of 4, we will have negative 42, 6 minus x to the power, that's 6 minus x, 6 to the power 4. And that will fill up the f double prime, f triple prime, and f4 of 0. So that means our f of x 7 ln of 6 minus x can be written as 7 ln 6, because that is the f of 0, plus negative over 6 x plus f double prime is negative over 6 squared times 2 factorial x squared plus negative 14 over 6q times 3 factorial x cubed plus negative 2 over 6 4 to the power 4 times 4 factorial x to the power 4. So turn out this is our C0, C1, C2, C3, C4. Okay. The only downside of this is it's gonna be harder for you to write to represent that at this series, and also to find the radius conversion is going to be harder, and you're going to have to show the step for that. So this is just recommended. The best way to do this problem is using the power series idea. Okay, the geometric series idea. So on the exam, you must use this way.